Hello, and welcome to SuccessIRies, the infrared professional's choice for advanced training and continuing education. My name is Jim Severin. I am an Infraspection Institute Level 3 Certified Infrared Thermographer and Director of Infraspection Institute. I will be your host and instructor for this SuccessIRies short course. This course consists of an online narrated PowerPoint presentation and is one of several short courses offered exclusively through Infraspection Institute's iLearnIR distance learning program. This course assumes that the viewer is generally familiar with the science and application of infrared thermography. This course is provided as continuing education and is not intended as a substitute for thermographer training and certification. This course does not purport to address all safety considerations associated with the performance of infrared inspections. It is the responsibility of the viewer to become familiar with all safety requirements and regulations pertinent to his or her work and to take necessary precautions to prevent personal injury. In no event shall Infraspection Institute be liable to anyone for special, collateral, incidental, or consequential damages in conjunction with or arising from the use of this training course. We thank you for choosing Infraspection Institute for your training needs and wish to welcome you to this dynamic and exciting technology. About Infraspection Institute. Before we begin today's course, we would like to take this opportunity to tell you a little bit about us. Founded in 1980, Infraspection Institute is the oldest independent infrared training and certification firm in the world. Infraspection's mission is to provide training, certification, and support for infrared thermographers. Infraspection is staffed by highly experienced Level 3 practicing thermographers. Our staff possesses decades of real-world experience in a wide variety of applications across a broad range of industries. Our experience and expertise are unmatched anywhere in the world. In fact, several of our staff are qualified as expert witnesses for legal cases. Infraspection Institute does not manufacture or sell infrared equipment, nor do we take commissions from the sale of infrared equipment. Because of this, our courses are presented without marketing hype. Our primary goal is to convey timely and accurate information to you, the student. At Infraspection Institute, we professionally promote infrared thermography through training, research, publications, software, and standards development. We are deeply committed to the promotion of thermography as a science and a profession. IR Info Conference. Another one of Infraspection Institute's training resources is our annual Advanced Training Conference and Technical Symposium, IR Info. We invite you to join us this coming January for the year's premier infrared event. At IR Info, you can enjoy 4 days of learning, networking, and fun in a relaxed yet professional atmosphere. At IR Info, you can enhance your credibility by learning new applications, hearing case studies, visiting our exhibitor showcase, test driving the latest equipment and software, and attending a wide variety of short courses. Our IR Info conference can also help to ensure your professional success. At IR Info, you can discover numerous business opportunities and learn how to increase your revenue and profits. At IR Info, you can also meet and share ideas with today's industry leaders. Our conference is well known for its family atmosphere and the willingness of our attendees to share their experiences with others. We are always on the lookout for speakers and presenters, and this year is no different. If you have an interesting tip, a new application, or a case study detailing how your company applies thermography or related NDT, we invite you to contact us. We have a number of incentives and can help you enhance your professional image by getting you the exposure you deserve. For more information, including special discounts or to register, visit us online at www.irinfoconference.com. This is SuccessIRies Short Course 102, Infrared Thermography for Home and Building Inspectors, a Hot Business Opportunity. During the past few years, interest in the use of thermography for home and building inspections has increased dramatically. Rising energy prices, consumer demand, and lower infrared equipment costs have led many home and building inspectors to consider adding infrared inspections to their service offerings. In addition to increased diagnostic capabilities, thermographers with the proper equipment, training, and experience can enjoy increased revenue and profits. This short course provides an introduction to infrared thermography, how it is applied to buildings and building subsystems, along with ways to ensure one's success. Introduction. The past few years have seen tremendous growth in thermal imaging for building inspections. Increased awareness of thermography, combined with lower equipment cost, has led many contractors and consultants to add thermal imaging to their services. Thermography is now frequently used to detect and document evidence of latent moisture as well as other building and subsystem deficiencies. While thermography expands the diagnostic capabilities of the building inspector, it also provides potential for additional significant revenue. This presentation will highlight several uses of thermal imaging, business opportunities, and advice on how to ensure your success. Introduction to infrared thermography. Infrared thermography is a form of non-contact, non-destructive testing. Thermography is completely passive, emitting no harmful radiation, and requires no downtime for the structures or systems being inspected. Infrared thermography utilizes a video camera-like device known as a thermal imager to detect and document thermal patterns across a surface. Some thermal imagers can also measure surface temperatures. Pictured here are several modern thermal imagers. Currently, there is a wide variety of commercial infrared imaging systems available. While prices vary according to imager capabilities, they all perform the same general task of converting invisible heat energy emitted by an object into a visible light image that is displayed on a monitor screen. Displayed thermal images are typically monochrome or multicolor, wherein the various shades of gray or color represent apparent thermal patterns across the surface of the inspected item or object. Most thermal imagers provide real-time imagery that can be recorded as snapshots or thermograms. Some thermal imagers also have video output jacks that allow thermal imagery to be recorded to a video recorder. Uses of thermography. Thermography may be applied to any situation where knowledge of surface thermal patterns can provide meaningful data about a structure, system, object, or component. Infrared thermography can be used for preventive and predictive maintenance, condition assessment of existing structures and systems, quality assurance inspections of new installations, repairs, and retrofits, and also for forensic or failure investigations of building structures and subsystems. Due to its graphic nature, thermography is often used as legal evidence in insurance claims and civil litigation. Because thermography can provide evidence of system or structural failures, thermographers may find themselves subpoenaed without warning to provide testimony regarding their findings. Thermographers who inspect buildings are especially likely to have their work product utilized as evidence when an inspection detects or documents material or system failures. Applications of thermography. Infrared thermography may be used to test a number of building systems and components for integrity and proper operation. Qualitative thermography, or thermal imaging, may be used to detect and document evidence of excess energy loss from insulated structures, to detect latent moisture within insulated roofs and building sidewalls, to inspect concrete masonry unit walls, to assist in damage restoration efforts, to locate pests and pest-related damage, and to check building subsystems for proper operation. Applicable subsystems would include but not be limited to electrical systems, mechanical systems, and HVAC systems. Over the next several slides, we'll examine each of these applications in greater detail. Detecting evidence of building leaks. In these thermal images, we see a portion of the exterior wall and floor of a newly constructed building. This inspection was performed from the interior of the building. Both images depict the exterior wall and floor of a heated commercial building being imaged from the interior. At the time of the inspection, the interior of the building was warm and outdoor air temperatures were cool. To eliminate errors caused by solar loading, this infrared inspection was performed from the building's interior during evening hours. In the thermal images, we see large amorphous cool areas on the wall and in the carpet. These dark areas are caused by latent moisture within the drywall and carpet. In this case, the wet areas appear cool due to evaporation of the moisture from the affected areas. Moisture trapped within building materials may permit the growth of mold or be attractive to insects. Damage restoration, wet drywall. In these monochrome thermal images, we see two different perspectives of the interior of a wood-framed building. Both images depict the ceiling and walls of an air-conditioned wood-frame building being imaged from the interior on a warm day. At the time of the inspection, the interior of the building was cool and outdoor air temperatures were warm. The infrared inspection was performed from the building's interior during daytime. In each of the thermal images, we see large amorphous cool areas on the ceiling. These black areas are caused by latent moisture within the drywall. In this case, the wet areas appear cool due to evaporation of the moisture from the drywall. Once again, moisture trapped within building materials may permit the growth of mold or be attractive to insects. Damage restoration, wet carpet. Thermal imaging may also be used for damage restoration to detect wet building materials. In this composite thermal image, we see a large cold area caused by water evaporating from a carpet. This office is being professionally cleaned and dried following a flood. The imager can also detect the presence of water in the vertical drywall near sections of wet carpet. Left untreated, moisture in the carpet or drywall can be conducive to mold growth within a very short period of time. Energy loss, missing insulation. This pair of thermograms shows reverse thermal patterns due to missing insulation. Warm vertical lines with cold cavities in between. These walls were inspected from the interior of the building with warm air inside and cold air outside. Visual inspection revealed no insulation present within these walls. This type of documentation is useful in solving comfort and performance problems and can play a key role in energy audits. Energy loss due to air infiltration. These monochrome thermal images show typical thermal signatures of cold air infiltration into heated living spaces. In the left image, we see a cold thermal anomaly, indicated by black finger shapes, caused by cold air infiltrating along the bottom of an exterior door on the first floor of a framed building. In the right image, we see another cold thermal anomaly, again indicated by black finger shapes, caused by cold air infiltrating along the baseboard and around an electrical outlet on an interior wall of a framed building. The thermal imager does not see cold air. Rather, it shows where the floor is cooler due to cold air infiltration. Once again, thermal imaging can help to detect the cause of comfort and performance problems within conditioned structures. Infrared inspections of flat roofs. Flat roofs are another application for thermal imaging. Applicable roof construction includes built-up or single-ply membranes installed over and in continuous contact with a layer of insulation or an insulating deck. Roof membranes may be smooth or gravel-surfaced, provided that the gravel is pea-sized or smaller. For insulated roofs, infrared inspections are typically performed post-sunset following a clear day. During daytime hours, wet insulation within the roofing system will absorb more solar energy than areas of the roof which contain dry insulation. At night, roof areas containing dry insulation cool rapidly, while roof areas containing wet insulation will remain warm for up to several hours after sunset. These warm areas form distinctive patterns that are readily detected by a thermal imager. In these thermal images, we see thermal patterns observed during a post-sunset infrared inspection of an insulated roof. In these thermograms, the pink areas are caused by the presence of wet insulation beneath the membrane. Both thermal images depict thermal patterns that are typical of highly absorbent insulations such as perlite, wood fiber, and glass fiber. In both images, invasive testing confirmed the presence of moisture within the roofing system. Once these areas have been identified with a thermal imager, they can be outlined with spray paint to help direct future repair efforts. Infrared inspections are useful for determining the condition of existing roof systems, or they may be used as part of an annual preventive maintenance program. They can also be used as a quality assurance tool for new installations or retrofits. Water infiltration into EIFS. For many, latent moisture within exterior insulated finished wall systems has become a major concern. Water infiltration into EIFS wall systems can cause significant structural damage in a very short period of time. In this image set, the thermograms show warm areas appearing as white amorphous shapes caused by latent moisture in a framed chimney detail. Following techniques similar to those used for solar-driven infrared inspections of flat roofs, this inspection was conducted from the building's exterior shortly after sunset following a clear day. Here, infrared imaging allows for a cost-effective inspection and provides information for the entire EIFS installation quickly. This type of documentation is useful for condition assessment of buildings prior to purchase or sale. This thermogram shows the exterior of a large condominium. At the time of the inspection, the interior of the building was warm and outdoor air temperatures were cold. Following techniques similar to those used for solar-driven inspections of flat roofs, this inspection was conducted from the building's exterior shortly after sunset following a clear day. In the thermal image, we see large warm areas on the exterior walls shown in pink. These pink areas are caused by wet insulation within the building's exterior walls. The finger shapes are caused by gravity pulling the water down through the insulation within the wall. In this case, thermal imaging was used to document the extent of moisture damage associated with EIFS failure. CMU Wall Systems. Infrared thermography may be utilized to inspect concrete masonry unit walls for proper placement of reinforcing grout details. In a properly constructed wall, one should see continuous vertical lines created by the presence of grout. These thermograms show warm vertical lines caused by grout details within CMU walls. Grout details should remain unbroken throughout the entire height of the wall. Infrared inspections of CMU walls are typically performed post-sunset after a clear day. The presence of grout is typically indicated by warm vertical lines whenever grout is present. Depending upon local weather conditions, infrared inspections of CMU walls may also be successfully performed at midday with sunny skies. In such cases, we expect grout details to appear as cool vertical lines wherever grout is present. Warm delta T caused by pests. In this monochrome thermal image, we see an irregular warm thermal pattern associated with rodent damage to insulation behind the drywall. This imagery depicts the knee wall of an air-conditioned wood frame building being imaged from the interior on a warm day. In this thermal image, the straight gray lines in the knee and end walls and slope ceiling indicate the presence of wooden studs and rafters. The darker gray areas indicate the location of insulation. At the time of the inspection, the attic space behind the knee wall was warmer than the living space. The irregular warm thermal patterns shown in white are caused by displaced and missing insulation where mice have created tunnels through the insulation. Similar thermal patterns may also be associated with larger rodents such as rats and squirrels. Electrical systems. Infrared inspections can also be used for building subsystems such as electrical distribution systems. In this application, any electrical device can be inspected provided that it is under load and protective panel covers have been opened or removed. Here we see 3 fuses in a 3-phase disconnect switch. In the thermal image, the center and right fuse clips exhibit elevated temperatures due to defective fuse clips. Performed annually as part of a preventive maintenance program, thermal imaging can quickly detect evidence of latent failures such as loose connections, overloaded circuits, unbalanced loads, and faulty equipment. Combined with timely, effective repairs, infrared inspections can help to reduce unscheduled downtime and prevent catastrophic failures. Mechanical systems. Thermal imaging can also be used to inspect mechanical equipment within buildings. Here, we see a motor coupling that exhibits uneven heating due to misalignment between the pump on the left and the motor on the right. Misalignment is a common condition in motorized systems that can significantly shorten the life of motors and driven equipment. Thermal imaging is also capable of detecting thermal patterns associated with worn bearings, under-lubrication, and improper belt tension. Thermal imaging allows for rapid detection of problems and real-time analysis of data. Combined with appropriate corrective actions, thermal imaging can help to extend the life of mechanical equipment. HVAC systems. In these thermal images, we see two examples of heating system failures. The left image shows 3 electric baseboard heaters to be inoperative. The right image shows cold air being introduced into occupied office space through the building's HVAC registers. Serious comfort problems in both of these areas had placed the building's insulation under suspicion prior to the infrared inspection. The infrared inspection found the thermal envelope to be of good integrity. Comfort problems were found to be caused by subsystem failures, such as the ones depicted here. Business opportunities. The use of infrared thermography in building analysis is accelerating, drawn forward by a perfect wave of market forces. These include rising prices for energy, a greater acceptance by the insurance industry, lower equipment costs, and competitive pressure. Thermography provides a diagnostic tool for building inspectors, allowing an inspector to detect conditions that might otherwise go unnoticed. Thermography can also enhance one's corporate image and can provide a competitive advantage over others that do not offer infrared inspection services. Perhaps most importantly, thermography can also provide significant revenue opportunities. Income opportunity. Unlike one-time inspections for energy audits, preventive and predictive maintenance applications of thermography represent repeat business. Commercial facilities routinely have these inspections performed annually, semi-annually, or monthly. There are considerable differences in the pricing and frequency of residential versus commercial inspections. Typically, residential inspections range from $0 to $250 per building. These inspections are one-time inspections, each of which must be sold on an individual basis. Commercial inspections typically range from $800 to $1,000 per day. These inspections usually provide for multiple days of inspection per year. Because most commercial contracts repeat annually, thermographers are able to build an ongoing book of business and develop a client list that provides steady, repeat business. The revenue potential for commercial work differs considerably from residential. The typical gross revenue for one thermographer and an imager ranges from $150,000 to $200,000 per year, based upon only 200 working days per year. Things to be aware of. As a home or building inspector, thermography can expand your existing services and increase your profits. Despite advertising claims to the contrary, infrared thermography is not a point-and-shoot technology. In order to help ensure accuracy and success, thermographers should be properly trained. At a minimum, we recommend Infraspection Institute Level 1 or higher certification. We also recommend that a thermographer thoroughly understand building construction and material performance. Thermographers should also possess additional training or certifications as required. Examples would include, but not be limited to, mold inspection and pest management certifications. In order to avoid a costly mistake and to properly select infrared equipment, we recommend that potential thermographers get trained before buying any infrared equipment. Beware of purchasing a camera that comes with free training. Such training is often biased toward a single brand or offered after imager purchase when it is too late to consider other options. Because thermography is a dynamic and evolving technology, it's imperative for thermographers to keep abreast of changes to standards, procedures, and practices. Infraspection training. At Infraspection Institute, we offer a wide array of training courses. These include Level 1, 2, and 3 Certified Infrared Thermographer courses. Open enrollment classes are held monthly and are open to the public. Upon request, Level 1, 2, and 3 courses may also be conducted on-site for individual companies or organizations. On-site classes allow for site-specific training and are often cost-effective for groups of 4 or more. Infraspection also offers several applications courses. Typically 2 to 3 days in length, course topics include, but are not limited to, infrared inspections of electrical systems, mechanical systems, building envelopes, roofing systems, and for pest detection. Customized courses are available upon request. Infraspection also offers several courses through our iLearn-IR distance learning program. These include Level 1, Level 2, and Level 3 Thermography, several applications courses, and our SuccessIRies continuing education short courses like the one you have just seen. For additional information on any of our training, we invite you to call us at 609-239-4788 or visit us online at infraspection.com. I'd like to take this opportunity to thank you for visiting SuccessIRies, the infrared professional's choice for advanced training and continuing education. Should you have questions regarding this presentation, you're welcome to email us at info@infraspection.com. We hope you've enjoyed today's presentation, and we look forward to seeing you again in the near future. Until then, I'm Jim Sefrin. Have a safe day.